right, we are on objective 2 practice of probability and sampling. So let's look at a couple examples. Jake is going to call one person from his contacts at random. He has a total of 30 contacts. 16 of those contacts are people he met at school. What is the probability he calls a person from school? Okay, so we are just doing simple probability, want over total. Okay, a person from school, there's 16 of those. That's what we want out of a total of 30. And now it says round your answer to 2 decimal places. So we're going to do 16, the top divided by 30, the bottom, and we get 0.5333 repeating. Okay, so we're going to round to 2 decimal places. So what does that third number do to the second one? It's just going to round to 0.53 because 3 doesn't make it go up. So we plug in 0.53. Excellent. Okay, Leslie is a biologist. She's going to randomly select one animal from her lab to study. There are 5 salamanders, 3 crayfish, and 12 minnows in her lab. What is the probability she gets a salamander? Okay, again, simple probability, want over total. What we want is salamanders, and there are 5 of those. And then we need the total. Add all those together, you get 20. Reduce that, turns into 1/4. That as a decimal is 0.25. If you didn't know that, you can do top divided by the bottom. Round to 2 decimal places, which is already 2 decimal places. And that's our probability. Okay, experimental probability. Now this is what actually happened when they did the experiment, when they tried the probability. It says the following histogram summarizes the number of points Nate has scored each game this season. Okay, so it says for 3 games, he scored between 0 and 3, 5 games between 4 and 7, 8 games between 8 and 11, and so on. Based on this data, what is a reasonable estimate of the probability that Nate scored 8 out of 11 points the next game? Okay, well, we can see, again, it's just want out of total, but it's not theoretical this time because these are games he actually played. So this is what actually did happen. But he did 8 games, that's what we want. 8 games where he got a score, he scored between 8 and 11 points. So that's our want. Out of our total, we need to add all of these games together. So this is 3, this is 5. So 3 games, 5 games, 8 games, 6 games. This is 2 games and 1 game. So add those together. That makes 8, 16. 16 plus 6 is 22, plus 2 is 24, plus 1 is 25. So 8 out of 25 is what we're looking for. So we scroll down, we see that on D, and we're correct. Good. Let's try another one. Pat's Pizza made 21 cheese pizzas, 14 veggie pizzas, and 23 pepperoni pizzas, and 14 sausage pizzas yesterday. Based on this data, what is a reasonable estimate of the probability that the next pizza made is not cheese? So we want everything but cheese. Okay, so we have 14, we have 23, and we have another 14. Add all those together. 4 and 4 is 8, plus 3 is 11. Then 2, 3, 4, 5, 51 pizzas is what we have. That is our total, so that goes on the bottom. What we want is, oh no, that's not our total. That's everything that's not cheese. So that is our want, because we do not want cheese. Now our total, we have to add another 21 to that. So 51 plus 21, 72. 72 pizzas total. So 51 out of 72. Now notice their answers are in percent form. So we're going to change that to a decimal first. Top number divided by the bottom number is 0.708. Round that to 2 decimal places. 0.71. Change that to a percent by moving the decimal twice. 71% is what we're looking for, which is C, and we're correct. All right, again, so basically just want over total yet is what we're doing. Manure randomly selects times to walk into a local restaurant and observe the types of music being played. She found that the restaurant was playing country 11 times, rock 17 times, and blues 8 times. Says use the observed frequencies to create a probability model of the type of music the restaurant is playing. Okay, so basically we're doing want over total 3 different times. So let's figure out our total first. So we have 11, 17, and 8. Let's add those together. 8 and 7 is 15, plus 1 is 16. We have 36 songs total. Country would be 11 out of 36. Rock and roll would be 17 out of 36, just using these numbers. Blues is 8 out of 36. So we can just plug those numbers in. Let's move this up here. We have 11 out of 36, 17 out of 36, and 8 out of 36. We can actually reduce that, and if we can, we should. So 8 can be divided by 4, and 36 can be divided by 4. 8 divided by 4 is 2. 36 divided by 4 is 9. So that would be 2 out of 9. 2 nights. All right, good. And one more. Now remember, probabilities always add up to 1. And one thing about probability is you can never have a negative probability. There can't be a negative chance of something happening. It could be 0, but it can't be negative. Okay? That'd be like going back in time or something. It's not possible. Okay, so it says, Tanner is watching a basketball game. The following table shows a probability model for the outcome of the game. Since it has a negative probability, we automatically know it is not valid. It is not possible to get a negative probability. So we can't do it. All right, here. Okay, these people are sharing a basket of fries. The following table shows an incomplete probability for who will eat the next fry. Okay, again, all the different choices add up to 1. So if we add up what we have so far, we should be able to figure out how the probability for Ronald. So we have 0.3, we have 0.1, 0.32. So we're going to add zeros behind those so we have the same number of decimal places. 3, 6, 7, 8. So 0.82 is all of these so far. So to figure out Ronald, we would do 1 minus 0.82, which is 0.18. So there is a 0.18% chance he will get the next fry. Now it says if there are 200 fries in the basket, which of the following is the best prediction for the number of fries that Ronald will eat? So his probability is 18%. He's going to get 18% of those 200 fries. So we're going to write a proportion actually to help us figure out how many fries he's going to get. So it's going to be our want and our total. So we want 18% out of a total of 100%. How many fries does he want out of 200? Okay, cross multiply, divide. Remember how to do that with proportions. 200 times 18 divided by 100 equals 36. So that means out of all 200 fries, he's going to get 36 of them. Okay, by figuring out what his probability was and then setting up a proportion. So that would be B, and we're correct. Okay, let's try one more problem where we have to set up a proportion. Okay, it says Sports World is open every day. Chelsea, Ivy, and James are the only employees at Sports World who can open the store. The following graph shows an incomplete probability model for who will open the store on any given day. So it's a 30% chance that Chelsea will open, 10% chance Ivy will open. What is the probability of James? Well, 30 and 10 makes 40. So if we're doing 100% minus 40, that means it's a 60% chance that James will open the store. Okay? Let's remember that. 60% chance now. Over the next 150 days, how many of those will James open the store? Well, we have our ones in our total. If he's opening 60 out of 100, then how many days will he open out of 150? Cross multiply, divide. So that looks like 90. 150 times 6 is 9,000. Divided by 100 would be 90. So 90 out of the next 150 days, he will be opening the store. Good. All right, that's all for examples. Let's get to our practice.